Are looking at lesson 5.4 today. Still working with radicals. Now we take the route of solving radical equations. Okay, you would have done a little bit with solving radical equations back in Algebra 1, but of course we go a little bit farther with it here. So, square root of x plus 5 minus 1 equals 3. Thoughts on where to begin? Guesses on where to begin? Patrick?
We can subtract the 1 from 5 and clean it up a little bit.
Unfortunately, we cannot. Why am I going to say we can't subtract the 5 and the 1 from each other?
That's under the radical.
Yeah, 5's under the radical, 1 is not under the radical. So unfortunately, they cannot go together.
Subtract 3.
I don't really want to do that. Lucy?
Adding the 1 on both sides.
I do like the idea of adding the 1 on both sides. Okay, what are we going to do by adding the 1 to both sides? This is a minus 1, and we add 1. What are we doing here? Any thoughts? So I'm now going to have the square root of x plus 5 minus 1 plus 1 cancels equals 3 plus 1 is 4. What have we done there by adding the 1 over? We cleaned it up. What did we get by itself?
Square root.
Square root. Okay. So we have that radical by itself. And that's our goal. Okay. So number one goal when you're working with these types of problems is start by getting the radical by itself. We have the radical by itself. Now, what can we do to both sides of the equation to make that radical disappear? Square it, right? This radical is a square root. So what's going to undo a square root? And that is going to be squaring it. Now, of course, if you square the square root, which means if you square the left side of the equation, then we're going to square the right side of the equation. What happens when you square a square root? We've already talked about this some this year. Yeah, the square and the square root cancel each other out. You get whatever's under the radical. So in this case, we're going to have just the x plus 5 remaining. On the right, what do you get when you square 4?
16.
Okay, 4 squared is 16, so you do actually have to square that piece. And now, how do we finish solving for x? Yeah, if it's x plus 5 to get x by itself, we're going to subtract 5. If you subtract 5 from one side, you're going to subtract 5 from the other side. So we're going to have x equals 16 minus 5 is 11. Okay. Now, so in terms of steps, okay, if we talk about some steps, your first job is going to be to isolate whatever you have, whatever type of radical it is. So, and if I kind of write some steps here, the first step is going to be to isolate the radical. So get that square root, that cube root, that fourth root, whatever it is by itself. And then after that, your job is to get rid of the radical. So in this case, we squared both sides. Okay, so your job will be to square both sides. Now, we'll talk in upcoming steps, will always be to square both sides. Not necessarily, because they won't always be square roots. Now, one thing I do recommend here, and I'll be honest, top section, not as necessary. However, when you square both sides of the equation, you can sometimes introduce extra answers that don't actually work. So my suggestion is that you get in the habit, and you can do this mentally. I'm going to write this one down, but you get in the habit of doing a check. In other words, if I plug 11 back in, does it work? So we came up with the answer of 11. Plug it back into the original problem before you changed anything. So then it'd be what? Instead of x, I'd have square root of 11 plus 5 minus 1 equals 3. Does it work? Does that mathematically make sense? 11 plus 5 is 16. So you have the square root of 16 minus 1 equals 3. Well, the square root of 16 is 4. 4 minus 1. Is that going to work? Does 4 minus 1 equal 3? And it does. Okay. As I said, that check doesn't have to be written out. I wanted to write at least the first one out in this section. Okay. As we get farther on, check will become a necessary thing. But right now, it's more of an optional thing in this section. Okay. Ready to try B? Cube root of x plus 2 equals 4. What do you want to do? Okay. In order to isolate that radical first, subtract the 2. Because is the 2 under the radical? It is not. Okay, so our job is to get the radical by itself. So we're going to keep the cube root of x as is. 2 minus 2 will cancel. And we're going to be left with 4 minus 2, which is 2. Okay. So that's kind of step 1. Isolate that radical. Now what? I have cube root of x equals 2. Okay. This isn't a square root, so we're not going to square both sides. This is a cube root. So we're going to cube both sides. So when I said square earlier, keep in mind that could be cube, that could be whatever it needs to be, right? So we're going to cube both sides. What do you think happens when you cube the cube root? They're going to cancel. And you're going to get whatever's under that radical. In this case, it's just an x. What about 2 cubed? 8. 2 times 2 is 4. Times 2 is 8. So x equals 8. And you're done. Okay. To get us in the habit, can you do a mental check there? Or if you want to write the check out, go for it. Okay, I'm going to save my writing the checks out for down below. But if I just do a mental check, and I take 8, and I put 8 in for x, the cube root of 8 is 2. 2 plus 2 is 4, and it works. Okay? You're always welcome to write the mental checks out, though. Okay, let's try C. Square root of x minus 2 plus 3 equals 5. What's step 1?
Subtract 3.
Okay. We're going to subtract the 3 to get the radical by itself. That 3 is not under the radical, so you got to move it away. So now I'm left with square root of x minus 2. 3 minus 3 cancels. 5 minus 3 is 2. Now what? What'd you say?
Square root. Yeah.
The opposite of square root. To get rid of the square root, we're going to square. Okay, we've got the radical by itself. It's a square root, so we're going to square. What is the square? What is the square root squared here? It is x minus 2. What is 2 squared? 4. And you're back to middle school equation solving, right? If it's x minus 2, we're going to add 2. And x is 4 plus 2, which is 6. Doesn't work. Is 6 good? 6 minus 2 is 4. Square root of 4 is 2. 2 plus 3 is 5. That's my mental check. I'm just plugging it back in and doing the math. Okay. One more in this section. Cube root of x minus 1 equals 2. Thoughts? Everyone wants to get quiet now? Let's go do that first step, Toph.
Cube both sides.
Cube both sides, right? Is that radical already by itself? It is, isn't it? Okay. That cube root's already by itself. So we're going to jump right into cubing. If you cube one, you cube the other. The cube root of x minus 1 cubed is going to be x minus 1. 2 cubed is 8. X minus 1 equals 8. Am I done?
No.
No, what do we got to do?
Add the 1.
Add the 1 over. Add the 1, add the 1. We get an answer of x equals 9. Do a quick check. Does it work? 9 minus 1 is 8. The cube root of 8 is 2. 2 equals 2. Okay. The basics, right? I don't know how much you dealt with cube roots in Algebra 1, but you definitely would have done this with square roots in Algebra 1, I feel like. Okay? Maybe not, but it seems like you would have. Okay. Ready to try the next section? As we move into the next section, notice what it says there in the middle of the page. It talks about something called an extraneous solution. Okay? And this is why I introduced the idea of checking already, because an extraneous solution is a solution that does not work when checked in the original equation. Because we are squaring both sides, or cubing both sides, or whatever we're doing, we are possibly creating extra answers that might not work. Okay? Now, the ones up above, I'll be honest, I expected them to work, because when I squared or cubed both sides, I just had a number on the other side. And so I know enough that I know it's probably going to work. On these, when you start looking at these, the difference is we've got some x's outside the radical. So this is going to kind of change things up, make the problems a little more complicated, and create some extra answers. So here it becomes incredibly important to check your solutions. You will sometimes have solutions that don't work. Now, the rules still stay the same. First step, or the steps I should say. First step is to get the radical by itself. If I have the square root of 3x minus 2 equals x minus 4. Is step 1 good? Yeah, I've got that radical by itself. Next step is to then what? Get rid of that radical. How do you get rid of a square root? You're going to square it. Okay. On the left, what happens when we square the square root of 3x minus 2? We're going to get 3x minus 2. On the right, not exactly.
Plus 16.
Not exactly.
X minus 4 plus 1.
Not exactly.
X minus 4 squared.
Well, right now, it is x minus 4 squared, yes? Here's my hint. X minus 4 squared can be rewritten as x minus 4 times x minus 4. What's the hint I'm giving you here? We need to, how do we multiply x minus 4 times x minus 4? FOIL. Okay, distribute if you prefer that vocabulary. So, I'm going to keep my 3x minus 2, and I've got to FOIL that right. Okay, that's the trick here. So, when we FOIL this, x times x is x squared. How fancy do you guys feel with me this morning? X times minus 4 is minus 4x. Are you fancy enough to go ahead and do the next one at the same time? Minus 4 times x is another minus 4x. What's minus 4x and minus 4x? Minus 8x. Is that too much? Some of you don't care. Some of you, I'm afraid. And then what's last? Minus 4 times minus 4 is plus 16. Okay. So beware of FOIL. Got to use all of our algebra skills. Okay, thoughts for solving steps from here. Because obviously our job is to solve from x. We got rid of our radical. What do you see in this equation? We have an x squared and we have x terms and we have number terms. What am I going to suggest making this equation equal to? 0. Okay. When you see x squareds, x's, and number terms, let's make it equal to 0. Now, you guys know what I'm going to say here, right? I like to keep my x squared positive, which means I'm going to make my 0 happen over here, if you guys can handle that. So how do I move my 3x and my minus 2? The 3x, I'm going to subtract 3x, and that's going to subtract from the negative 8x. The minus 2, I'm going to add 2, and that's going to add to my 16, keeping those like terms together. So clean it up. If done correctly, your left should be 0. On the right, let's see what do we have. X squared. We had minus 8x, and now we're subtracting 3x, and that makes it minus 11x. We had plus 16, now we're adding 2, and so now we have plus 18. Well, okay. Algebra skills, how do we solve? I need a little more detail than just carefully.
You multiply to, or you add to negative 11, you multiply to 18.
Okay. Two numbers that multiply to be 18, add to be negative 11, meaning what are we hoping to do? We are hoping to factor. Okay. Are they going to factor today? For the most part, I would say yes. I don't dare say guaranteed to factor, because as soon as I do that, something's going to jump out and surprise me. But mostly you can expect factoring to happen. Okay. So remember, x squared breaks into x and x. Multiplying to be 18, what'd you come up with? Okay, negative 9 and 2, right? You need 9 and 2 to get 18 and add to be 11. In order to multiply to be a positive, they have to be the same sign. In order to add to be a negative, they're both going to be negatives. So we have x minus 9 and x minus 2. Now that we have those two factors, we do what with each of them? We're not done yet. We have to set each of them equal to 0. So x minus 9 equals 0. X minus 2 equals 0. When we solve these, I'm going to get solutions of 9 and 2. And we circle our answers and we move on.
Got check.
You could, but you're probably going to get something wrong. Or there's a chance you're going to get something wrong.
So we don't.
Okay. We're going to check. Okay. I guess, you know, in Savas, you can play the chance of, you can try it, and if it tells you they're wrong, then start guessing around. That doesn't work on a quiz or a test, right? You don't have something telling you automatically it's wrong. So take each answer, plug them into the original. I'm going to have to scoot B over here. I'm going to try and squeeze in a check. So if I plug in 9, the square root of 3 times 9 minus 2 equals 9 minus 4. Okay, so notice I'm plugging 9 in. Both places there's an x into the original before I squared anything. So this is going to be square root of 3 times 9, 27. 27 minus 2 is 25. 9 minus 4 is 5. Square root of 25 equals 5. Yeah, that one would be good. 5 equals 5. Try your other one. what is it, 2? So square root of 3 times 2 minus 2 equals 2 minus 4. 3 times 2 is 6. 6 minus 2 is 4. So I have the square root of 4 equals 2 minus 4 is negative 2. It's sort of right, but in this scenario, the square root of 4, when you just have a positive radical here, the square root of 4 is 2. Does 2 equal negative 2? No, it does not. So guess what? 9 worked, 2 did not work. Bless you. Okay. And again, you don't have to write the checks out. Okay? That's me trying to be helpful because I know some people are going to struggle a little bit to see what I'm talking about. So I'm making sure everyone can see what I'm meaning when I say check. Okay? But if you don't feel the need to write that check out, don't. Okay? I'll be honest, when I'm doing this on my own, I don't write these checks out. Okay, you ready to try B? X equals square root of 7x plus 8. First step is what? Square. My square root's already by itself, right? So we're ready to square both sides. So when I square the x, I'm going to have x squared. When I square the square root of 7x plus 8, I'm going to have 7x plus 8. You square the square root, you get whatever's under the radical. Okay. I got rid of my radical. I've accomplished that goal. What's next?
Okay.
Move it to where it equals 0 so we can factor. Okay. In order to make this equal to 0, you pick what you want to do. I'm never going to factor with a negative x squared. So if I move my x squared to the right and make it negative, then I'm going to multiply everything by negative before I start factoring. Okay. I tend to just do it in one step though and say, okay, I'm going to move my 7x and my 8 over to the left. So I'm going to subtract 7x and 8. So we're going to have x squared, subtract the 7x over, subtract the 8 over, and that equals 0. I'll take the fronts of the parentheses. X squared breaks into x times x. What do you got for numbers?
Negative 8 and 1.
Okay. Negative 8 and 1 multiplies to be negative 8. And negative 8 plus 1 adds to be negative 7. Okay. So that's good. Set each factor equal to 0. If it's x minus 8, we're going to have an answer of x equals 8. If it's x plus 1, we're going to subtract 1 and have an answer of negative 1. What am I going to say before we move on? You've got to do a check here, okay? There was an x outside the radical that we squared, so we very possibly created an extraneous solution, okay? So we do a check. I'm going to plug 8 in. So go to the very original. So 8 equals the square root of 7 times 8 plus 8. 7 times 8 is 56. 56 plus 8 is 64. The square root of 64. 8 equals 8. That one checks. What am I plugging in? Negative 1. negative 1 equals the square root. Whoops, that wrote weird. Negative 1 equals the square root of 7 times negative 1 plus 8. I'll be honest, I can stop right there. Why can I stop right there? You cannot have a radical equal to a negative. Okay? The radical is only asking for the positive root. So it's not going to happen here. I mean, if you keep going, it's the same type thing where, okay, 7 times negative 1 is negative 7, plus 8 is 1. You have the square root of 1, but you end up with negative 1 equals 1. Okay? When you have a radical equaling to a negative, that's not going to work. So automatically, you know right there it's not going to happen. Okay? Here's what I'm asking you to do. Give C a try. And we'll start talking about that. We'll start off talking about that tomorrow. Okay? Give C a try. If you want my recommendation, I'm going to say move the radical over to the right to make it positive and add the 2 over to the other side. I am going to take 2 steps there. Okay? But we'll talk about that tomorrow. Savas should be out there and available. Okay? If you want to get started on some of the easier ones. If you look at the back side, we've not talked about when there's 2 radicals in a problem, and we haven't talked about if you, instead of having a radical, you have a fraction exponent. So we'll talk about those tomorrow.